So this is the summary of the derivative of the natural log function. The derivative of the natural log of x is 1 over x, and the domain is for x is greater than 0. When we take the natural log of a function, we use the chain rule, and that derivative is going to be u prime over u, and u is greater than 0. And then the extension is the natural log of the absolute value of x, which is equal to 1 over x. All right, so let's use these derivative formulas to take the following derivatives. And so I want to take the natural log, the derivative of the natural log of 8x. So dy dx is going to equal 1 over u, so 1 over 8x, times the derivative of what's inside, which is 8, or the derivative of u, which is going to be 1 over x. Second one here for b, this is a product rule. So use y prime. It's going to be first times derivative of the second, and the derivative of the natural log of x is 1 over x, plus second, which is the natural log of x, times derivative of the first, which is just 1. So here the derivative is going to be x times 1 over x is just 1, plus the natural log of x. All right, now in this problem right here, y equals the natural log of x to the fourth, we can use one of the derivative formulas because the exponent is on the argument, and we can rewrite that as y equals 4 times the natural log of x. And now we just have the derivative of a constant times the natural log of x, and so y prime, or dy dx, is going to be 4, you get to take the constant out of the derivative, times the derivative of the natural log of x, which is 1 over x. And so the derivative is just 4 over x. Now, if you forgot that property, that you can bring the 4 down in front, you can still do the problem. In this case, we'd get y prime equals, it's basically 1 over u times the derivative of u. And so we would get 1 over u is going to be 1 over x to the fourth times the derivative of what's inside, which is 4x cubed, and that will cancel and simplify to 4 over x. I highly recommend taking advantage of the properties of logs. You'll see in a few of the problems that we're going to do that understanding the properties of logs makes the derivatives much easier to find. Now d is a little bit different. You have to be careful here because here you cannot bring the 4 down in front. The property says if you take the natural log of an expression raised to a power, then that power will come down as a factor, but you cannot take, this is now a whole logarithmic function raised to the fourth, and so what we're really thinking about when we're thinking chain rule is that outside function is really u to the fourth. So y prime is going to be 4 times the natural log of x raised to the third power. Now we have to take the derivative of what's inside. The derivative of the natural log is just 1 over x. And so we might tidy this up a little bit. We could write this as 4 times the natural log of x whole thing cubed all over x. Now you've got to be really careful. The difference between having those parentheses and not writing them in is the difference between a correct answer and an incorrect answer. All right, let's look at this next one down here using another property of logs to help in the differentiation here. The natural log of the square root of x plus 1, can be written as the natural log of x plus 1 to the 1/2, and that 1/2 can be written as a factor, which is 1/2 the natural log of x plus 1. This is a much easier derivative to take. And so when I take f prime of x, Again, this is just a constant, so it's going to be a constant times the derivative of the natural log of x plus 1. Well, it's going to be 1 over u, which is 1 over x plus 1, times the derivative of what's inside, which is just 1. And so the answer, or the derivative for this function, is going to be 1 over 2 times x plus 1. If you did not remember the property and understand that you can write the square root of x as x to the 1/2, if you took that derivative, it would be 1 over u. So the derivative of the natural log of the square root of x plus 1 is going to be 1 over the square root of x plus 1 times the derivative of what's inside, which would be 1 over 2 square roots of x plus 1. And then the derivative of what's inside there is just 1 times 1. And so when you rewrite this, you're going to get 1 over, when you multiply the square root of x plus 1 times the square root of x plus 1, you just get x plus 1. So again, in this case right here, the difference between using the property and rewriting the expression and not is not that big. Both of them are reasonable derivatives to take. But when you come down and look at this next problem in example 3, you're going to see that if you don't use the properties of logs, and you're going to have almost an impossible derivative to take. All right, so for this derivative, we have the natural log of both a quotient and a product, and we've got an exponent. And so what we want to do here is we definitely want to rewrite this as the sum and difference of logs, and also use the whole idea of square roots and rewriting with fractional exponents. And so before I take the derivative, I'm going to rewrite this as the natural log of x plus 3 times the natural log of 8x plus 1 minus 1/2 the natural log of x minus 4. And now when I go to take the derivative, f prime of x, I just have 3 fairly reasonable log expressions to take the derivative of. And so the derivative of the first piece here is just going to be 1 over x. The derivative of the second piece, it's going to be 3 times, and now I'm going to use the u prime over u notation. It's a little bit easier here. So I'm going to get 3 times. Well, in the denominator, I'm going to have 8x plus 1. And then the numerator, I'm going to have the derivative of what's inside, which is just 8. I've got u prime over u minus, same thing, I've got 1/2 times, in the denominator, I'm going to have u, which is x minus 4, x minus 4. And in the numerator, I'm going to have just u prime in this case, which is just 1. Now you shouldn't leave your answer like this. You should tidy it up a bit. You do not need to combine these into one fraction. You can leave them separate. This is going to be 1 over x plus 24 over 8x plus 1 minus 1 over 2 times x minus 4. So what I'd like you to do here is pause the video and do these 4 problems, and then, actually I think there are 5, do 5 problems, and then start the video up again to check your work. So the first derivative, this is the natural log of u, and u is 7x, so we would have y prime equals, it's 1 over u, so 1 over 7x times the derivative of what's inside, or we can just put that derivative right in the numerator, and you're going to get 1 over x. So when you've got, you can see that when you've got that constant times x, the derivative is just going to be the 7, and the 7 is going to cancel, so you're just going to get 1 over x every time. Now in this problem right here, you can use the, you can rewrite the expression or not rewrite the expression. If you don't rewrite it, we get f prime of x. It's 1 over u, which is x cubed, times the derivative of what's inside, which is 3x squared. When you simplify that expression, you're going to get 3 over x. This next one right here is the product rule. Y prime equals e to the 2x, the first times derivative of the second, which is 1 over x, plus second, natural log of x, times the derivative of the first, which e to the 2x, so the derivative of that is going to be 2e to the 2x. Same thing, I want to tidy this up a little bit. I'm going to write this as e to the 2x over x plus 2e to the 2x times the natural log of x. I'm going to leave that as the answer. The reason why I often bring that expression in front is so that it doesn't get confused with the natural log of x. All right, the last, number 4, this is not a problem where you can rewrite the expression. Remember, u is the natural log of x here, so f prime of x is going to be 3 times the natural log of x, in parentheses squared, times 1 over x. And so I'm going to get 3 over x times the natural log of x squared. And then the last one, I'm going to rewrite this using sums and differences. It's going to be 4 times the natural log of x plus 3 minus the natural log of x minus the natural log of x minus 1 to the 1/2. I just expanded this log by bringing the exponents down as factors. Any log expression in the denominator is negative. G prime of x is going to be 4 over x plus 3 minus 1 over x. Easier to bring that 1/2 in front. So I'm going to get minus 1/2 times 1 over x minus 1. And again, we should tidy that up a little bit. 4 over x plus 3 minus 1 over x minus 1 over 2 times x minus 1. And for these derivatives, I will not make you combine the terms. And so we're going to leave our answer as is right there.